Hello, I'm going to walk you through the set of exercises on nucleotide sequences using the Ensembl database from EBI. 1. Search for the gene sequence using HK1 as a search term. What is its Ensembl ID? So to do so, we have to open a new tab, find Ensembl, and click on the genome browser. Because we're supposed to look for human HK1, we select human as a species and we don't enter any other textual search, just those letters HK1, because that refers to the gene name. Now the Ensembl gene ID, the entry ID is given right here in the first hit, so we don't need to do anything further other than copy it and paste it into our template, and that's our first question. 2. How many base pairs does the longest protein coding transcript have? So we have to click on it to get into the entry and then see the transcripts. There's a transcript table and we can see they are ordered in descending according to descending length, and so the largest will be the top one, and it has a number of base pairs which is 3998, which we can copy and paste in our template. So these are the base pairs, so I can as well specify BP base pairs in that longest transcript. How many transcripts are listed and how many of them are protein coding? Let's go back to our list so we can see, if we scroll a little bit up in about this gene has 18 transcripts. So here's the full list of 18 transcripts and we can see the longest are protein coding, so we just count how many there are. 2, 4, 6, 8, 10. So there are 10 protein coding transcripts out of 18. So we can bring that in. We have 18 transcripts and 10 out of them are protein coding. 4. Where is the gene for the human hexokinase 1 located? So let's see, if we scroll up to the entry, we can see there's actually a location tab. And clicking on the location tab, we get right at the top the answer to our question, which is, if I copy that, this gene is located on chromosome number 10, base pair 69 million, and so on, a little bit of that sequence. 5. Which genes do you find next to the HK1? One left and one right. Write down the gene names and the corresponding protein names. So let's go to our entry and see. In the regional view, we can see that our HK1 is already centrally located in the middle, and one to the left would be up here HKDC1. And first, we only look at the golden ones. To the right would be TACAR2. So we just take that information directly and put it into our template, saying left is HKDC1 and right is TACAR2. Now concerning the protein names, of course, an easy way to do it is to open a new tab, going into Ensembl again, and just get it from there. So if we assume that is meaning also look for the human entry, so HKDC1 will give you an entry here. Without further clicking on it, you can see the name. It's hexokinase domain containing 1. So copying, pasting it here, maybe slightly a bit more nicely, hexokinase domain containing 1. And similar, just going back here and putting TACR2 as a search name, we find TACR2, the human gene, and that encodes a protein called tachykinin receptor 2. So if we bring that back and paste it in here, we have answered our question. Search for paralog genes, number 6. How many are there and what are their names? So let's go back to our entry for HK1 and see how we can get to paralogs. So I click on the gene view here, and when it loads, we can see on the left-hand side in the navigation bar that there's an entry for paralogs. So once that loads, I can hide the transcript table to get it up. We can see there are 1, 2, 3, 4 listed, and their names are HK2, HK3, GCK, and HKDC1. So I just take that directly. How many are there for paralogs? And their names are HK2, HK3, GCK, and HKDC1. Seven. Is the chromosomal neighborhood of the hexokinase gene conserved in the autologs of the cow and the mouse? So there's two things answered, right? You compare to the cow and you compare to the mouse and comment on conservation. And I take that to mean the immediate neighborhood. So let's see how we can find orthologs. If we scroll up again, we can see just above paralogs are the orthologs. So we click on it and we get a long list of orthologs. And rather than going through them one by one, I just search cow. And in the entry for the cow, which is Bos taurus in Latin, we have compare regions. So clicking on it, we get a comparison of the regions, where if we just concentrate on the immediate neighborhood, we have already seen it. It's HKDC1, then HK1, and then TACR2. So let's see what the cow has. And if we look at the cow, we can find HKDC1 as well. We have HK1 centrally and TACR2 on the right-hand side. So we can say immediate neighborhood similar or same. Well, let's say similar because it's not the same. And that goes for the cow. Let's do the same thing again for the mouse. So we go one step back to the list of all the orthologs and we find the mouse. So then let's see what type of mouse. We take the ordinary mouse, which is Mus musculus, and again click on compare regions. So if we compare the regions, we remember the human, HKDC1, HK1, TACR2, and scrolling down to the mouse, Mus musculus, we can see TACR2, HK1, HKDC1. So the same genes in the immediate neighborhood, but in reversed order, because we're looking at the forward strand here. And so what we can say is, to make that very quickly, in the mouse we have same genes, similar gene, but reversed order. That would be one very short answer to this question number 7. And And finally 8, using the Biomart tool of Ensembl, how many protein coding genes in men are located on human chromosome 10 nucleotides between 69 million and 71 million. And then we have to check gene ID and gene name only. Can you find hexokinase 1? Well, we suppose so, because we just saw it in chromosome number 10, 69 million and something. So we expect it to be there. But then the final thing is try to find MIM morbid descriptions. So let's do that and see how we can achieve an answer to this question. So if we go at the top of the homepage under More, we can find Biomart. So there's a link to the Biomart interactive interface. And we first have to get our preparation in a new search. So our database will be Ensembl genes, and having talked about the humans, we look at the human genes. Now we have to select filters, and the filters will be set by, if we are asked to look for a certain chromosome, pick a chromosome, and it was, in this case, it was chromosome number 10. So let's check in chromosome number 10. Scrolling down, there's a possibility to enter coordinates directly. So we select coordinates and we say, what was it? 69 million. So 1, 2, 3, 4, 5, 6 zeros. And that goes up to 71 million base pairs. So these were the pieces of information that we were given and that we now say search in here. Right? And as the attributes out, we want to have something related to the gene, and we were told to look at gene stable ID. So we leave gene stable ID, but we unclick all the others. We don't need to see all of those things. In addition, we need the gene name. Where's the gene name? Just here on the right hand side, we can see gene name. We'll click it and we'll get it out, as you can see on the list of attributes on the left hand side as well. Now, slightly more tricky is to find the MIM morbid descriptions, but knowing that MIM is a separate database, we need to go all the way down to external, and expanding the external, we can see that there's somewhere all the way down there are MIM entries. So we were asked to look for morbid descriptions, and so we can click morbid descriptions. It's now entered to the list of attributes, and we hope to see them all in our results table. So after we have entered all that we need, we click on count, and that will not give us the results. It will just show us how many results are there. So 53 is a good number. We can just look at it, and we want to see all those results. So by default, Biomart gives out 10, but seeing that we have 53, I think we expand that to 100 to just see all of them. And no, we don't want to see doublings, especially not in the gene, so we can look at unique results only. Now we were asked whether we can find hexokinase 1, gene of which is abbreviated HK1. Yes, of course, we can see that in the table. There's a couple of entries for HK1, and you remember there was many different transcripts relating to it, so there are multiple hits returned. And under the morbid descriptions on the right column, I'm not going to look at all of them, but you can see Charcot-Marie Tooth disease, for example, and others. Let's just take one example from the beginning right here, which is hemolytic anemia. And so yes, we found something. So our answer to that question is yes, found. I mean HK1, yes, found. And MIM, morbid e.g., I just put one example here, and it's hemolytic anemia from the MIM database. Clicking on it will get you to the MIM entry, and you can look up further there.